Hello my friends, CFD analysis with Butterfly from the Ladybug tools together with OpenFOAM, video number 3. After a rough week with lots of work, I finally have some time to further explore the script we started in the last video. If you don't know what I'm talking about, check the link in the description or here. Yeah, so I cleaned my script a bit, as you can see here. For each section, I just create a group, kind of easier to handle. Of course, here's already an item which is not in the group, but sometimes it's very handy to have it like this. If an item is not in the group, you just click the group, click the item, and right click and say add to group, and it's added. Perfect. Because there's another thing not added. Doesn't matter. I haven't checked into this section here yet, but what I thought would be good to actually get a Windrose. This is done with the normal Ladybug Windrose and data set. What you need to get is, depending on where you are, the new Ladybug tools or the legacy tools, depending on what you have. It works pretty much the same. You need the weather data, and you can see that in one of my previous videos. I did a video about the Windrose, so you should just check that out. So basically it's using the climate data from any dataset you want. We looked also on how to get the map and so on. Then we load this into our E plus weather data file import tool, and that gives us an annual Windrose. And we can of course move this away because we have our model here. So we can move that away with just create a point and maybe move it here. But that gives us a bit of information about, so this is Cardiff, and in Cardiff, the main wind direction is southwest. And most time of the year, you have a wind direction this side. The highest winds during that time is around 11. That's quite a lot. And actually maybe even a bit more, sometimes up to 16 meter per second. Important. And that's always measured. What I understood is that this is the average speed, or the wind speed measured in 10 meter height, because the wind speed increases the further up. So I added this, and then in my model I thought maybe it would be interesting to have a hole in the model and see how that works. Yeah, I added a legend. I added a legend, so we can actually compare our output with the wind speed, or so we have a color coding, and then we know what are the speeds actually in our model. And I will explain a bit more about that later. Then I was playing with the wind vector. I haven't got completely the hang of it. It seems like there is a bit of an issue. So I tried, based on Ilya Savchenko. Thank you, by the way. Ilya Savchenko, he had the suggestion to use the points, and it works, but not always. And it's so basically in here. So if I don't use the wind direction, if I don't use the wind vector, then it doesn't create anything. So you need to have an input here. And I disconnect the vector for now, and then we add this here. And this creates my tunnel, where the wind comes from the south. So if I want to have the wind coming now from this direction, I thought, okay, let's, so what is the highest wind speeds? If I want to check the wind speed would be then around 16.5, as we read here. So we can see that goes into the deep orange, which is around 16-18, so let's say 16.5, and the wind direction. And I thought, okay, let's do the same. Let's try the method. So I will just get the vector component, which is this one. This is the vector component, and I just put a base point, and an endpoint. And then with this the vector display tool, you can then make this vector visible, just to see what it is. Now I'm not convinced yet with this because it rotates my tunnel, but it causes some issue here in the in the grading tool. And the funny thing is, it works sometimes and sometimes does not. So if I put this here, it suddenly works. If somebody has a suggestion why and what the problem is, then please tell me, because I really don't understand. It's interesting. And maybe, I don't know, we'll keep it like this for now. And yeah, if somebody has an idea why this doesn't work, let me know. I've just put the test project wind speed away from here. I also put a point, and I will explain in a minute. Put this here. But what you can do, of course, you can always rotate your model. This already ran, it's fine. And then we had the block mesh, and again, we can set a different cell size if we want, but for now we keep it. Okay, that works. That works too. Let's have a look. Okay. And this is also not 100%. Yeah, so I took it off because it feels like it also doesn't work with on how it's generating the grading, and I'm probably need to find out more about that before we move on with this kind of vector stuff. It seems not 100%. I don't know how to do it, or probably that's the reason, and that's why let's keep it as it comes in. What we always can do, we can always rotate our model, then if we have at least this reference here, then we know how we can rotate our model. That's the other workaround. Okay, so we ran the block mesh, and that looks good as well. So I turn this off, and let's then run the snappy hex mesh again. It seems like I did not turn off this here. So let's check if that worked with my hole in the middle. Yes, it worked. Again, it's a bit sloppy here, you can see. And we should fix that. If you run a more serious script, then you might need to refine that here, the refinement level. But for testing, it's fine. I'm very curious how that works. So okay, and now in here so two things what I want to explain. First, what does the U actually mean? Because in the previous video we actually didn't talk about the units, so we didn't actually know what we're testing. We were testing something, but we didn't know what that is. And U is they call it fields. It's called fields. And basically what's happening when we're testing, or when we run this solution, then the calculation happens. So from my understanding, in all of the blocks of the the snappy hex mesh, in all of the cells there happens some calculation, several calculations. I'm just trying to mentally, or I try to just to picture it. And what we do with the probes. So in the previous video, we actually created a grid, a plane which created points, and these were our probes. These were our specific points where we want to make the calculation visible. And because there were some questions about why can they not be 3D, and why do they have to be in one plane? They don't have to be in one plane. You can manually put a point into the space, and that's the point you want to test, or you want to make the calculation visible. I think that's. I hope I explained it correctly. At least that's how I understand it. So you basically can do all kinds of things. You can, what I did here, for example, is creating a point cloud. So I'm creating a box. Let's create a box here. Turning this off again so we can see it better. I'm creating a box here. Idiot. And well, let's make it bigger. For example, create a box, and then with my Pop 3D tool, which is in here. Wait, I forgot where it is. I always forget these things. Here. So in that one, you can actually populate 3D points in space. And you can say how many you want. For example, 2000. It looks like this. And that's also possible. So basically, then all my points within that cloud of points are probes at the location where I want to test or where I want to make the calculation visible. And the field of what I want to make visible, I need to put in here. And this is basically a shortcut for what kind of thing you want to make visible, what kind of output you want to see. So in order to find out what it is, I actually had to look up the OpenFOAM wiki. So there's a website called openfoamwiki.net. And here is actually a table of common fields. And these are the fields you can test. And U stands for velocity, meter per second. And then you have, for example, P is the pressure in, I guess, in Pascal. The turbulence kinetic energy is K, for example. So there you have it. So there you know what is U, what U actually means. So that makes it more clear now on what we're doing, because we know that the field we want to test or make visible is U. And again, from the solution, we want to load the probe values of the field U again. So we know, okay, all the values we're getting from our probe points are basically it's the velocity of the wind. That's what we're getting. And I think that's quite, yeah, it's quite important to know, to understand. Okay, let's run this so get a better understanding. Oh yeah, I also what I want to test here in this video is the turbulence models. There are two turbulence models, and if you click here, actually, it's what I really like with Ladybug is that you can always click on and you can actually read the code. And there's actually more to it. Gives you a suggestion on where you can learn some more about the turbulence, and there's even a YouTube video where you can watch what the turbulence model does. And again, here in Butterfly, you can actually see also here the turbulence models, and it also gives you it actually shows you the YouTube video where you can watch or where you can learn more about it. Yeah, we can actually go in. Let's look at that. Gonna copy this. And OpenFOAM user guide V8 turbulence. And it explains everything about the turbulence models. And because I'm for sure want to read that at some point, but I'm also, interested in just testing it. I love just to play around with it. So I thought maybe we test it without and then with and see what the difference is. And this now is just trying to give you an idea that you can generate all kinds of point clouds, but we might make it smaller later to actually test the turbulence better. So let's run this. Yeah, what I love is that you can actually watch the calculation doing its job. So here, I want to explain a bit more about this. So I changed a lot here. Right, I didn't change a lot actually, but I changed some stuff. First, what I did And that's actually a student brought me to that. She was asking me why is so actually before it was like this, right? She said, why are the different vectors, why are these smaller and these are longer and bigger? Well, because the vector, making the vector visible, actually shows the length of the vector, which is equivalent to the speed of the wind. So the faster, the longer the vector. And we were able to just change the size with the slider. But I felt she has a point that it's actually not, it doesn't help that much to understand. It's actually depends if you have like a black and white, if you use black and white, if you use only black vectors, then maybe that works quite well because you get a different texture. But in our case, in this case with the colored vectors, it's actually more, it might be better if you see them all in the same length and then you just have the color code. It could be actually better, and you can see even in the slower speeds on how they move, on where they move. So that's why what I did here is actually before I color the vector, I actually parameterize them. So I go in here and say, sorry, unitize. Unitize, it's called unitize. So I call unitize, so they make them all one. The length of the vectors becomes all one. And then I feed it back into that multiplier so I can control the size. And that goes back then into the vector display X. And yeah, they're all the same length. Let's see how that looks in the rendered viewport. Yeah, it's quite interesting. And it's actually not so bad. You see, what you also see that the wind speed becomes more the further up. So if I would measure, let's measure here 50 meter, yeah, you can see 12 in 10 meter height and how it is in 60 meter height. Quite much stronger winds on the top. So what else did I do? Is it still? No, it's actually the calculation is finished. Yeah, a bit more about this here. So again, so I can change the size. That's all great. Looking from the top gives me some interesting pattern. We still have the problem with with these values, and somebody suggests that they are in the these are the values which, or these are the probes which are inside the massing of these objects, and that's pretty sure this is correct. Still have not yet the idea on how to remove this, but we still see it. So 31 is the maximum, so we need to adjust that here, no? 31, and that gives you a better distribution of the color. And also, it's quite crazy how this moves around. I mean, you could for example here create a clipping plane and then go through the different sections. That could be interesting. If I have two of them and I flip one of them, then I could look at the different levels and see how that changes. Yeah, it worked really good. It goes through this hole here. It just needs more density in some areas just to get a really good picture. Yeah, so further, I feed this, sorted all the numbers, and I think it's not necessary. I don't think you need to sort them out, but I did anyway. Let's remove this here. And then I added a legend. The legend is here in the Ladybug tools. Create a legend, this one. You feed the values in, all the values go here, and can give it a name. You can say, if you want, you can have it. Yeah, so this is the title, and then you can add parameters. So that helps you to actually recolor or give it certain index colors. So you can actually change different colors. I'm using the normal standard Ladybug colors. Thought they are working quite well. And then I also use the same colors in my gradient. So I have a very good understanding of how the wind behaves in my model. And then I use my maximum. I also use in the legend parameters. Parameters. This is this one. Legend parameters. Here you can give the maximum. A minimum I keep it with 0. and a maximum width, then the same number as I'm using here. And then you can, if you want, you can change the segments. That means you can change the amount of segments you want here. And then with the index, you can change the different colors. If you hover over this, you can actually see what they are. So there are a lot of different ways to visualize your legend. It's a bit difficult. I haven't found out if I can actually use the same colors here. Could be actually work. Could that work? I'm not sure. I mean, yes. I mean, I can, of course, use the same colors, but automatically, I'm not sure. Maybe I can feed these numbers somehow in. In any way, I can then say if it should be vertical or normal. Vertical or horizontal, sorry. I actually like this quite a lot, so it's the text goes along with the wind speed. And then I can also change the size, of course, and the text height. And you can also, of course, change the font. I'm fine with the font. I think it's Arial or something. And of course, the legend. That's basically it. Now let's turn this off and we try the turbulence. If there's any difference. I'm just changing the box. Okay. And now the moment of truth. Oh yeah. Yeah, let's test first without the turbulence model. Wait, let's get the other ones. I need to still learn about this, but just for the sake of playing with it, let's add it here and let's see. And let's just run it like this. There's quite some downdraft happening. The longer it runs, the more iterations you have, the more accurate it becomes. So I would also then always check your maximum, and if it's still the same. $31, yeah. Almost 32. Not artistic. Arctic. Yeah, this looks cool. What's also cool is you can take this and export it. No, save as. And SVG, scalable vector graphic. Open. Yeah, can actually open that in Illustrator. Or what I'm using is Affinity Designer. I might make a tutorial about it sometime. It actually shows the vectors inside the building. That's weird. Why Affinity Designer, you ask? Well, I cannot afford Illustrator. Simple as that. Yeah, so I think it won't change much anymore. It's just refining and refining and refining. That's fine. Let's check our maximum here again. 31.3. So it also doesn't change much. And now, so we know how that looks like. I'll also make a screenshot. And now we're gonna run this again with the ERA-S model. And I just use it as it is. Let's see. Yeah, it's different. It adds some layer of detail here, which we didn't have before. Almost looks like a Van Gogh. You know, the stars. In China, they often have this, like, you know, holes in the buildings for the dragon to fly through. It's actually not a good idea. Create some wind tunnel effect. Just joking. Maybe in some cases it's necessary. Yeah, let's finish. And okay, let's make a screenshot. Let's try the other one. Let's try the other model, the other RAS model. Still need to find out how that works with restarting these. Purge what's in there. Now we're using the other turbulent model. Let's see how that looks like. I mean, at the end, it's not about how it looks like, but if it's realistic or not. And for that, we need to read first what that actually means. But yeah, I love that we can really look at how the wind goes through. Gives a pretty cool idea how the wind interacts with the buildings. So in the next video, I really need to find out how to remove the vectors inside. I mean, I know how to do it in Grasshopper, but I imagine there's some option or tool within within Butterfly which actually does that for you, and I don't have to write a script for it or create a script for it. This model also has a different output, and it certainly takes longer. It's slower, but let's see the difference. This was the final one. So this was the first one. Second, there's quite a difference here. And this is pretty much the same as the other one. I need to really understand. And this is also very different. Some more turbulence here. Whereas here it's going back up. Yeah, so I would recommend to check out this and maybe also the YouTube videos suggested in the different turbulence models. Again, you can click here, double click, and check it out. Let's open it. Let's see what it does. So I think here you can learn everything about it, more than I can ever tell you. But yeah, we will continue. Don't worry. See you next time. Oh yeah, if you like my content, just subscribe, hit the bell button, and if you have any topic I should cover, let me know. Oh yeah, the vector. If anybody has an idea how that works, I couldn't figure it out. Wait, our friend wrote us this. Let's check it out. Savchenko uploaded everything on the Google Drive on what he did. Let's see. So he put the vector here. Interesting. So I guess in his case it might worked, but yeah, I don't yet get it. So he wrote, Philip, you can try this way. I spread the script just before connecting. You need to turn off the calculation, and the points controlling the vector should be in the field of the plane on which the vector is provoked. Yeah, we'll find out more soon, hopefully. Okay, see you.